Now, in Part A, what we're looking to do is this. We want 5 people are planning an event for a day in January, which has 31 days. And what's the probability that without consulting each other, so it's all independent choices, the 5 people will all choose January 11th. So let's write it this way. What's the probability they all choose January 11th? So what has to happen here is we've got 5 people. 1, 2, 3, 4, 5. Now the first person has to choose, or at least one of them has to choose January 11th, and that's going to be 1 out of 31 chances. The second person also has to choose that date. The third person also that date. The fourth person and the fifth person that date. So they all have to choose January 11th. There's 31 days and only one January 11th. So the problem here is solved if we just write this as 1 over 31 to the 5th. Okay, when I did this, I got this number here, 3.4929 ... times 10 to the negative 8. And then if we make this put this from scientific form into regular standard form, this decimal point is going to go 8 places this way, giving us 1, 2, 3, 4, 5, 6, 7 zeros and a 3 and a few other numbers. But if we round off to 4 places, this probability of this happening is essentially 0. Now in Part B, we're asked what's the probability they all choose the same day. So what we want here is the same day. So what has to happen here is that there's 5 people, 1, 2, 3, 4, 5. Now the first person can choose any one of the 31 days out of the 31 days of January. But the next person out of those 31 days has to choose the same day, so there's only a one-shot chance of doing that. And then the rest of these people have to choose that same day. So we're going to get 1 over 31 to the 4th. And 31 to the 4th, let me see what my calculator says here. That says, okay, this says this is about 1.0828 times 10 to the negative 6, which is still going to be, if you buy 5 zeros, 1, 2, 3, 4, 5, and a 1, that's still going to be essentially 0. And then in Part C, what's the probability that they all choose different days? Well, I'm going to look at it like this. Out of these 5 people, 1, 2, 3, 4, 5, the first person could choose any one of the 31 out of 31 days in January. And then the next person, out of those 31 days, could choose any one of the 30, right? Because we don't want this person here to choose the same one here. So take out that day, and now there's only 30 days from which to choose. And then the third person out of those 31 days, any one of those 29 out of 31, then any 30, and then, whoops, not 30. I'm counting up instead of down. How about 28, and then 27 out of 31. And when I computed this, if I typed everything correctly on the calculator, I got 0.7122 if I round off to 4 places.